Welcome to the short introduction of the trial delivery service of Nowcast products. This is a collaborative research project between the Bureau of Meteorology and the Smart Water Fund, with the key stakeholders being the Victorian water industry. The Bureau's nowcasting technology provides high spatial resolution radar rainfall estimates and short duration rainfall forecasts for either the next 90 minutes or 12 hours, which are called nowcasts. The delivery system which has been developed are the interactive map, web map services, and the FTP data feed. I will go into these with more detail later. On this landing page, there is also a case study of a rain event from 2014, which can demonstrate the functionality of the services if you are exploring the site on a day without rain. If you have any suggestions or questions for the Bureau of Meteorology, click here to be taken to the online discussion forum that has been developed for this project. Further help on how to use the prototype services can be found in the user guide link. There is also a link to the current fully operational Bureau of Meteorology weather forecasting service METI and the radar service showing observed rainfall. Finally, more information about the project itself and the final report can be found on the Smart Water Fund project webpage, and a link is available at the top of the landing page. The live interactive map has been developed for early identification of upcoming rain events of interest and is mobile device compatible. Please note that this service works better on browsers such as Chrome, Safari and Firefox. It only has a small range of functionality and is not expected to replace the Water Authority's in-house weather feeds via the WebMap service or FTP service. The maps may take a minute or two to load. If the Bureau decides to make this a fully supported operational service, a necessary enhancement will be to improve the loading speed. You can change the background map based on your preference. The minimum option is for faster loading. The square bounding box indicates the boundary of this trial service over central Victoria. There are 5 products on display, and 2 have a live loop functionality. First, the Blend 1440, which is the total rainfall in the last 24 hours or 1440 minutes, updated every 30 minutes in millimeters. You can see some areas there is no rainfall recorded because radar coverage does not extend there. This product is a blending of radar and rain gauge information, and you're able to click on gauges in this product to see the amount of rain recorded at the gauges in the last 30 minutes. The second product is the 5-year IRR probability, which displays the maximum probability of exceeding the 1 in 5-year return period rainfall in the next 6 hours. This is updated every 10 minutes. The ARI calculations have been performed over the next 12 hours and at each pixel, and therefore does not replace the Water Authority's calculations over longer time frames and catchment sizes of interest. However, it provides a quick indication of the storm's intensity. This product will need to be updated when the Water Authority start to adopt the Intensity Frequency Duration IFD design rainfalls currently being developed by the Bureau. The third product is the ARI Max Frequency, or on the screen ARI Freak Max, which displays the maximum ARI return period recorded in the last 6 hours over all periods starting at 10 minutes and ending at 6 hours. The fourth product is the Observed Forecast 180, which is the 3-hour 180-minute Looping product. The looping control can be turned on by clicking here, and the speed can be adjusted with these buttons. Each frame can be manually cycled through using these arrow buttons. The legend can be turned on to see more clearly the timestamp for each frame. This product is displaying rainfall in millimeters for every 3 hours, showing the past 6 hours and the forecast 6 hours. The legend can be turned on to see more clearly the timestamp for each frame. The first number, minus 30 minutes in this case, refers to the time of the observation, in other words 30 minutes ago. The 11:30 to 14:30 refers to the accumulation period, starting at 11:30 and finishing at 14:30. And then the final field is the date in year, month, and day. The fifth product is the observed and forecast 10-minute, which is the 10-minute accumulation, showing observed and forecast rainfall in 10-minute intervals accumulated in millimeters. This starts for the previous 60 minutes and goes to the maximum lead time for the next 90 minutes. For the two looping products, you might notice changes to the data coverage, and that is because the observed rainfall in the past is limited by the radar coverages, whereas the forecast and Nowcast products cover the entire area of the bounding box. You can click on Help to go to the user guide, or click on Home to be taken back to the home page. Use the Web Map service if you want to download and ingest a live feed for visualizing the data on your internal systems, such as a GIS. The same product as shown in the interactive map are available, as well as additional products that were identified during stakeholder consultation. The products are separated into observed rainfall products, that is historical data, and the forecast products. Click on one of the products to connect to the feed, then click on one of the .nc files. This page gives the GIS system on your end the information that is needed to connect. If at any time the feed stops working, just check back here to make sure the links to the server have not changed. Refer to the user guide if you have any issues. Use the FTP service if you would like to download Nowcast data for post-processing, as the files are most compact in this size. There is an archive available, a 10-day archive for the hourly products and a 3-day archive for all the other products. These are the same products as are available on their interactive map. To connect to the feed, click. For users who do not have the capability to process netcdf files, the .nc files, the Bureau of Meteorology has developed a format converter which goes from NC to CSV. To download the converter, click on this link and download the zip file. This zip file contains 3 programs that are needed to be installed on your PC. Usually the administrator access is required. After the programs are installed, save and run the converter, which is a script written in Python. Python is open source, so anyone can further modify the script to meet their own needs. There is also a user guide to explain how to install and operate the script. This script converts a single NC file to CSV. This script takes 2 files, converts both to CSV, and combines the data together. This may be used when you want to join historical observed rainfall with forecast rainfall into one file.